this theorem about circles and tangents. So without a loss of generality, we're going to restrict ourselves to this circle with center at 1 on the x-axis and the line x equals 0, which is your y-axis. So this is going to give us a system of two equations. An equation of the circle is the quantity x minus 1 squared plus y squared equals 0. This is our center, and the y-axis has equation x equals 0. Well, here's the system, and we want to claim here that the y-axis is tangent to the circle, and the point of tangency is the origin. So we solve this system, by substitution, x equals 0. If x equals 0, we have minus 1 squared plus y squared equals 1. We have 1 plus y squared equals 1. And then we have y squared equals 0. So y equals 0. And we have the only solution to this system is the point at the origin. So that might be the point of tangency. There's a y-axis might be tangent to this circle at the origin. However, we would do a more complete job if we were to consider every other line through the origin. And in order to do that, we'll just draw one. Here's another line through the origin, any other line through the origin, and an equation of this line is going to be y equals mx for some constant m, which is the slope of the line. So now we're going to solve another system. Here's your system. Look at this, is every other line through the origin has an equation, y equals mx, where m is some real number, some constant. So here's our equation of the circle, and here's our equation of any other line other than the y-axis through the origin. Let's see what this system yields. So we have x minus 1 squared plus mx quantity squared equals 1. We get x squared minus 2x plus 1 plus m squared x squared equals 1. These ones will cancel. So now we have m squared plus 1 quantity times x squared by collecting the x squared terms. Now we push the minus 2x to the right side of the equation. No, we're not going to do that. We're going to just say minus 2x equals 0. Now we're going to factor the common factor is x. So now we get, we're going to get x equals 0 or x equals 2 over m squared plus 1. But 2 over m squared plus 1, remember m is any real number. That's not going to be equal to 0 for all values of m, and not going to be equal to 0 because the numerator is not 0 and the denominator is greater than or equal to 1. So now we have two solutions. This is the solution that we already obtained in the other system. And the y value over here, we substitute into the simpler equation. And we get that the y value is 2m over m squared plus 1. So there are two distinct solutions to any other line through the origin. So that really ensures that the y-axis is the unique line tangent. And we can repeat this for by symmetry and similarity with any other point on the circle. And what we do get for free here is that the tangent is perpendicular to the radius drawn to the point of tangency because the x and y axes are perpendicular to each other. So that's how we show here in using the methods of Algebra 1 that we have a unique tangent.